The next skill we're going to talk about is raising fractions to higher terms. Now, normally you would do this if you were working with adding fractions or subtracting fractions. And when you add fractions or subtract fractions, what you're supposed to do is make sure that these denominators are changed to become the same denominator. So this is one of the rules, or this is one of the rules when you add or subtract fractions, though we're not going to go through that because, again, the GED test doesn't ask us to manually add or subtract or multiply or divide fractions, so we don't even worry about it. But raising fractions to higher terms is something that you might want to know how to learn, well, to learn how to do, because when you start dealing with something called ratios, and specifically proportions, which are fractions, you will be changing these fractions and you will be in either increasing or decreasing them. So I want to go ahead and demonstrate what I mean by that. Okay, so let's go ahead and go and take a look at a couple of these examples. So you'll notice on this page here, what I'm doing is I'm giving you a fraction. Okay, so I give you the fraction 3 of 5. Now, I'm gonna use the word fraction, but I'm also want to use to introduce you and make sure that you understand the word ratio. This is actually maybe a more important word than the word fraction. So I'm going to go ahead and use the word ratio. Just understand that it means also fraction, or another way to think about it. They are the same thing. Okay. So here's the thing. If I give you the ratio 3 of 5, okay, and then I say this, I want you to take the numerator. Okay, I'm going to go ahead and highlight it. I want you to take that numerator and I want you to change it. I want you to change it. I want you to change it to become a 12. Okay, so we're going to use math. Okay, and in fact, we're going to use multiplication in order to change this 3 to look like a 12. So I would ask you, hey, what number do I have to take 3 by? What number can I take 3 with and multiply it by something to become 12? You would say, well, 3 times what is 12? You'd say, well, that's 4, Varen, right? I'd say, yeah. Actually, if I want 3 to look like a 12 or to become a 12, I would have to multiply it by the number 4. Okay, so the rule of this is this: when you're working with fractions or ratios, if you change one, like for instance, we're changing this numerator here to become 12. If we're changing this thing, which means we're multiplying it by 4, then we also have to do that same action to the denominator, the bottom number. We can't just leave it 12 of 5. That would be incorrect, because if we're looking at 3 of 5, one thing I would ask you is, let's talk about 3 of 5. I would say, is 3 of 5 whole? You would say, no. 3 of 5 is not complete. And in fact, if we actually were in decimals, I'd say, what is 3 of 5 as a decimal? You would say, well, that's 3 divided by 5, and that's 0.6. I'd say exactly. So here's the thing. This value, or 0.6, what it's actually worth, right, through the division, showing this as a decimal, it has to be the same. It can't change. Even though the fraction looks different, remember we talked about equivalent fractions? When I'm changing this fraction, I can't change its value. It has to also be 0.6. I can't change that. So I have to show equivalent fractions. So because I multiplied this 3 times 4 to become 12, I need to do the same to the denominator so that I have an equivalent fraction. So if I take 5 and I multiply it also by 4, I will get the number 20. And guess what? If I take 12 and divide it by 20, let's go ahead and do that just so you can see it. You're going to see that this fraction is actually the same. So let's go ahead and take 12 and divide it by 20. And you're going to see that it's also 0.6. See, it didn't change value. These are equivalent fractions. So all I really did was just change how it looked. Now, you might be saying, well, Varen, why would I even do something like that? Well, when it comes to math, normally we don't do stuff like this. When it comes to adding or subtracting fractions where denominators have to change, yeah, you would be doing something like this. But when it comes to ratios and proportions, we will be doing techniques and skills that actually involve stuff like this. Let's try it again. Okay, so remember what we did is I asked you, I said, hey, you have the fraction 3 of 5. I want you to change it so that your numerator is now 12. What does your denominator have to be in order for that to happen? Remember what we said. I said, what do you have to multiply 3 by to become 12? You said, oh, well, I have to multiply by the number 4. So I said, yes, if you have to do that here, then you must also do it here. So you have to multiply by 4 here. So that would become 20. I want to go ahead and add a vocabulary word in to this lesson right now. Let's talk about that number 4. That number 4, or what we multiplied by in order for 3 to become 12 and 5 to become 20, that's called a factor. So I would say, what factor? Let me give it to you differently, because this is the way the GED test will talk to you. It might ask you, what factor do you have to multiply by in order for 3 of 5 to become 12 of 20? And you'd say, oh, well, you have to multiply by the factor or the number 4. Let's try again, okay? In this next situation, I give you 8 of 10. And I say, hey, let's go ahead and change it. Now you'll notice that when you look over to the right, you'll notice, hey, well, where's the numerator? It's missing. I'd say, yeah, I didn't give you the numerator, but notice that I did give you the new denominator, right? I gave you the new denominator. I said, okay, so the denominator is supposed to go from 10 to 40. Oh, okay. So I'd say, okay, remember, you have to use multiplication in order for it to go up. I want to change it from 10 to 40. What do I have to multiply 10 times for it to become 40? Did you say 4? That is correct. You have to also multiply 10 times 4 in order for it to become 40. So the truth is also that you have to do the same to the numerator. I have to multiply by the same factor, 4, in order for this to become an equivalent fraction, right? In order for 8 of 10 to be the same as what? 8, 16, 24, 32 of 40. In order for these things to be equal or equivalent, I have to change them both by the same factor. So now they are both equivalent fractions. 8 of 10 is worth the same as 32 of 40. And if you ever want to prove it to yourself, or you're like, I'm not sure, Darren, if I'm doing this right. Did I do it correctly? And say, okay, first, show 8 of 10 as a decimal. And whatever 8 of 10 is as a decimal, 32 divided by 40 should also be as the decimal. So not only are these fractions equivalent, their decimals should also be equivalent. So if I take 8 and divide it by 10, 0.8, 32 divided by 40 should also be the same. And if it is, then I have equivalent fractions. 0.8. Okay, let's go ahead and look at these last two. I'm going to call this first one A. I'm going to call this second one B. I want you to go ahead and do A. You'll notice that the denominator on the right side is missing. Can you go ahead and fill it in with the number that should be there? Go ahead and pause the video and do that. All right. So again, in order to figure out what that missing number is, you have to use the clues that were given to you. You'll notice that the 6 is being changed to an 18. So that's your clue. That's how you know, well, where do I go? Or what do I have to multiply by? Well, in order for 6 to become 18, you have to multiply by 3. So that's the factor I'm going to be using to change this fraction. So if it's 6 times 3 to become 18, then I also have to do the same to this denominator. So 14 times 3, I'm going to go ahead and use my trusty calculator because I do not trust myself. So 14 times 3, 42. So that means this missing denominator is 42. Let's try B. Again, you're missing the denominator on the right side. I want you to go ahead and figure out what it needs to become. Okay, did you pause? Did you figure it out? Let's go ahead and do it. So again, on this one, the clue is on top with the numerators. You'll notice that 7 became 28. So I'd say, well, what did you multiply 7 times to become 28? You'd say, oh, well, I multiplied it times 4. I'd say exactly. 7 times 4 is 28. So that's the factor I'm using. So if I multiply 7 times 4 to become 28, I also have to do the same to 9. I want to multiply 9 times 4, which will also become 36. And this is now my new equivalent fraction. 7 of 9 is the same as 28 of 36.